Our next unit is mixtures and solutions. Now, when we talk about mixtures and solutions, a lot of times maybe what's going through your head is, well, mixtures are like cereal or muddy water or salads. But, and you've probably talked a lot in middle school about different types of mixtures, especially in how they're classified. Um, and possibly even solutions. So we're going to get a lot deeper into the concepts of mixtures and solutions, primarily solutions, but there are a couple of types of mixtures I do want to talk a little bit more about, more detail. So with mixtures, and then we have solutions, and we'll be discussing the topics of solvation, solubility, and rate of solution, concentration. But first I want to talk about mixtures. So mixtures are when we have a set of two or more substances that retain their own properties. So while a compound, they change their properties, and mixtures, they don't change their properties. We have lots and lots of different types of mixtures that can happen. But typically, we classify them in two categories, heterogeneous and homogeneous. A heterogeneous mixture, as you've probably all heard before, is when we have substances that are not spread out uniformly. An example of this is sand with water. Another example of this would be like oil and water. But we also have another type of mixture called a homogeneous mixture, which is where the term solutions comes into play. So homogeneous mixtures are when we have substances that are uniformly intermingled. So like when we dissolve salt in water. Let's get more into detail though, first with heterogeneous mixtures. So we have a few types of heterogeneous mixtures I want to talk about. The first type is called a suspension. Then we have something called thixotropic mixtures, and then we have colloids. So first in the category of heterogeneous mixtures is suspensions. Here we have a mixture that contains particles that settle out if it's left undisturbed. So muddy water is one of the best examples, most easy to visualize examples of a suspension. If we pour a suspension through a filter, we should be able to separate out the solid suspended particles from the liquid particles that are being basically with the other part of the mixture. So we have two phases, and because we have these two phases that are dealing with particles that are fairly large in size, we get this separation that occurs. This is an example, this picture is an example of a suspension where we have oil, water, and we have some other stuff in there. It looks like maybe some sand. So that's an example of a suspension. Next, we have our thixotropic mixtures. Now, when you think of something like toothpaste, you may be thinking, well, that's kind of like, it's almost gelatinous, but when I put it on the toothbrush, it acts kind of like a solid. And then when I brush my teeth, it almost acts like a liquid. And so this is in the class of substances that we know or refer to as non-Newtonian fluids. There are 5 classifications here, but we're only really talking about one right now. And this one, the viscosity decreases. Viscosity is the rate of flow. So the rate of flow, the viscosity of the liquid or solid or whatever this thing is, this mixture, will increase. In other words, it's going to flow better when we agitate it or we stir it. So the most classic, the easiest to understand example here is toothpaste, because when we're brushing it on our teeth and it's interacting with our saliva and we're moving it and we're agitating it with the toothbrush, it acts like a liquid. Now, next I'm going to ask you to think about each of the pictures that I've got up here and how, as a combination, they're all similar. So we have mayonnaise, gems, clouds, butter, blood, whipped cream, smoke, and marshmallows. So take a few minutes, take a few seconds and just think for a moment about how these are all related to each other. Okay, so you probably started off with, okay, they're mixtures. Okay, what kind of mixture? I mean, we're in the category right now. We're talking about mixtures. So what category of mixtures would these be? Okay, so I won't waste your time anymore. The classification, and maybe you know it and you already said it or you already thought it, the classification here is what we call a colloid. Okay, so we have several types of colloids that exist. Now, particles that are in a suspension are much larger than the atoms that can settle out, and the atoms settle out of solution, excuse me. Now, a heterogeneous mixture with what we call intermediate sized particles. So particles where the size is between 1 nanometer and 1,000 nanometers in diameter don't settle out. We call this a colloid. Now, particles here not settling out means that they are just kind of staying suspended. So it's kind of like a suspension, but the particles are smaller and they stay within the mixture. They don't fall out. They don't settle out. So an example of a colloid would be milk. The components of homogenized milk can't be separated by settling or by filtration. So when we talk about a colloid, the most abundant substance in the mixture is what we call the dispersion medium. In other words, what everything else is being dispersed into. And we can categorize the colloids based upon the phases of the dispersed particle and their characteristics as related to the dispersing medium. So when the dispersed particles of the colloid, they're prevented from settling out. And this is because they often have charged groups, or polar or charged groups, on the surfaces. And these areas of the surfaces attract positively or negatively charged areas of the dispersing medium particles, resulting in the formation of electrostatic layers around the particles. Now, the layers repel each other when the dispersed particles collide, and this causes that situation where the particles are remaining as a colloid. Now, if you interfere with the electrostatic layering, colloid particles are going to settle out of the mixture. So, just bear with me here as an example, and maybe even something you could try. Ask your parent for permission first. Take, primarily just because I don't want you wasting their materials, but take a container, and in this container put some salt and dissolve the salt. Then I want you, so that is an electrolyte. Now I want you to take some mayonnaise. That was one of our colloids that was shown here. And kind of put the mayonnaise in there and just kind of mix it a little bit, agitate it, and just see what happens. Do the particles stay as a colloid? Well, I'll go ahead and tell you so that we can move on with the lecture and the lesson here that they don't. Your particles will start settling out. And this is because the electrolyte is interfering with this attraction and repulsion that's going on, keeping the colloid particles dispersed. So they clump together and it destroys the colloid. Another thing that you could do to destroy the colloid is heat it. So this causes enough kinetic energy to be there to overcome the electrostatic forces and eventually settle out. Now, we have lots of different types of colloids. We have colloids where they're dispersed, the particles are dispersed in solids, the particles are dispersed in liquids, or they're dispersed in gas. And in each of those, we have different possibilities. A solid in a solid in a liquid in a solid, a liquid dispersed in a liquid, a gas dispersed in a solid, and so on. So let's first talk about if some stuff is dispersed throughout a liquid. So let's say that we have gas dispersed throughout a liquid. We call these foams. So foams, like shaving cream or whipped cream, are considered colloids. Another one is when we have liquids dispersed throughout liquids. A classic example here is mayonnaise, as we mentioned earlier. Another example would be milk. Then we have, oh, and by the way, those were emulsions. The next ones are what we call sol. These are when we have solid particles dispersed in a liquid dispersion medium. Best example I can think of here and that I put here is blood. Blood is a mixture of lots of things, but it has solid particles that are suspended, that don't come out of the suspension because of electrostatic interactions. Pigmented ink and gelatin also fall in this category of sol colloids. Now, when we move into talking about colloids where the medium that's doing the dispersing is a gas, and we have other things dissolved, or not dissolved, excuse me, dispersed into a gas, what we have are, when we have liquid dispersed in a gas, we get what we call a liquid aerosol. Hairspray is a good example of a liquid aerosol, but fog and clouds are also examples of liquid aerosols. And if we enter an electrostatic, excuse me, not electrostatic, if we enter an electrolyte, excuse me, into a cloud, the water particles are going to cause the liquid particles are going to clump together, leading to rain. So there is actually something that's done with clouds sometimes called cloud seeding. And what they do is they take electrolytes and they spray electrolytes into the cloud to cause the dispersion of the particles to be interrupted, leading to rain. Now we also have a solid aerosol, and this is when we have stuff like smoke or dust that's in the air. This is a solid dispersed in a gas. Then our last category of dispersion medium here is solid. When we have a solid foam, we have gas that's dispersed in a solid, so marshmallows or pumice, lava. Those are examples of solid foams when we have a colloid containing solid that has gas dispersed throughout it. Additionally, if we have liquid dispersed in a solid, we get what we call a solid emulsion. So we had a liquid emulsion where we had liquid dissolved in a liquid. And now we have a solid emulsion where we have liquid dispersed in a solid. Butter and cheese are classic examples here. And then lastly, we have solid sol. This is when we have a solid dispersed in a solid. And I see that I made an error here with my spelling, not in solid, but in solid. And a good example here are colored gems or colored gemstones. So this is what we call colloids. Now, if we take a colloid that is one that we can see through pretty well, and we shine a light through it, what we're going to see is the light gets dispersed by the particles. And this is something that we refer to as something called the Tyndall effect. But that's not the point of what we're getting into. What we're about to get into is the other type of mixture, homogeneous mixtures, which is really what the rest of this unit is about. So we have these heterogeneous mixtures, and now we're moving into homogeneous mixtures. Homogeneous mixtures are when we have those two phases that will combine and be indistinguishable from one another in a single phase. So solutions are what we refer to here. When we have a homogeneous mixture, we have a solution. Now, that doesn't mean that we're dealing with always liquid solutions. We can have solid solutions. We can have gaseous solutions. The air we breathe is a classic, a perfect example of a gas solution. It has a solute and a solvent. So all solutions will have a solute and a solvent. The solute is a substance that's going to be dissolved in the other substance. The solvent is the substance that's doing the dissolving. So the solute is the one that we have less of, while the solvent is the one we have more of. So we have more water with salt water. So salt is the solute, water is the solvent, giving us a solution we refer to as salt water. The solution is still a mixture. It's just one where the particles are indistinguishable to the naked eye from one another, and they can't just be filtered out. Or you could maybe boil it out, but you can't use just classic filtration methods to deal with it. So the air around us we refer to also as a solution. Carbonated water is a solution. Ocean water, a solution. Antifreeze, a solution. Vinegar is a solution. Ocean water, again, is a solution. Something that used to be used in dental work, but it's not used anymore. It's called dental amalgam. Dental amalgam used to be used in creating fillings. So when you see people that have the metal fillings in their mouth, that's what dental amalgam is. But it contains mercury, which is a neurotoxin. So we have phased that out from dentistry. Now, another example of a solid that is a solution is steel. Steel is composed of iron and carbon. And so we get this solution that's a solid. Now, again, a solution is a homogeneous mixture where the solute is the substance being dissolved. The solvent is the substance doing the dissolving. It's what's there in greater amount. So, in this image, we have something called potassium permanganate. And we're saying we have aqueous potassium permanganate. What is our solvent here? Well, what do we have more of, the potassium permanganate or the water? When you look at this, do you see more of the potassium permanganate or more of the water? We know water's not naturally purple. So the purple stuff must be the potassium permanganate. So what do we have more of? Water. So the aqueous solution is when we have something dissolved in water, where water is your solvent. The solute is whatever you're dissolving in the water. So we refer to water as the universal solvent because so many things can be dissolved in it. But there are some other things that can't be dissolved in water. Anyway, so our solute is potassium permanganate, the solvent is the water. Now, here we have Coca-Cola. Here in Coca-Cola we have this solution. And its ingredient list has carbonated water, high fructose corn syrup and or sucrose, caramel color, phosphoric acid, natural flavors, caffeine. What is the solvent? So the solvent here is what we have the most of. And if you look at an ingredients list on anything, whatever you have most of, whatever's used in the most amount, the greatest amount, is always the first ingredient listed. So in Coca-Cola, your first ingredient listed is the carbonated water. Therefore, that is your solvent. So, the solutes are everything else that's being dissolved. So, if we have any solution that contains water as its solvent, we refer to it as an aqueous solution. And we've discussed this a lot in the past, but I just want to reiterate it one more time. So, again, water being the solvent means we have an aqueous solution. But not all solvents, or not all solutions contain water as a solvent. Other common solvents in the liquid phase would be things like carbon tetrachloride, which is used in dry cleaning, or acetone. Acetone is something we use a lot in the organic chemistry laboratory in order to dissolve the organic compounds that are nonpolar, stuff that won't dissolve in water. Now, this is the extent of today's lesson. Next lesson, we're going to be getting into a little bit more to do with the details of forming solutions and solubility and how we express concentration of a solution.